If I could literally get any part of this entire video to sink in, let it be right here, right now, this little clip. We do not want to train inefficient movements. If you perform this properly, you're not only enforcing proper running mechanics, you are maximizing mechanical efficiency and you are reducing wasted energy. And when a game's coming down to inches and minutes on the clock, you need this energy. Do not do this wrong. All right, here we go. I haven't made one of these videos in a while, but here we are, back at it, learning things on the internet. Imagine. Anyways, I'm making this video because there's an exercise I commonly see performed incorrectly, and it's one of those staple exercises that's very effective at improving lower body power output, especially unilaterally. And because it's such a foundational exercise, if we can't get it right in its most basic form, then we're going to have a lot of trouble progressing into more complex variations and getting more benefit out of those variations. Because ultimately the problem I'm seeing just falls back on basic movement mechanics, so we need to get this right first. So the exercise that I'll be talking about today is the single leg jump. So what I often see with individuals doing single leg jumps is they'll perform this big double arm swing as if they're performing a normal vertical jump. And while we want this double arm swing on a normal vertical jump because we can use that momentum to help carry us into the air and get more height on our vert, unless of course you're just trying to look at pure lower body power output or RSI, and you may want to eliminate that momentum by having the individual put their hands on their hips. But in the single leg jump, this is not what we want. And maybe you were taught this way, that's totally fine. I'm not saying it's wrong, but it's wrong. And I'll tell you why. So our single leg jump mechanics are very heavily derived in our running mechanics. And I'll put up one of my older videos here to show you what I mean because I'm too lazy to record a new one. So with the single leg jump, we actually want to have an alternating arm drive, similar to as if we are running or sprinting. As you can see in the video here, as I'm jumping off of one leg, the opposite side knee comes up, and then I get this unilateral arm drive on the side that I'm actually jumping off of. And then on the side that my knee is driving up on, my arm comes back. So what happens when we're running is we're propelling off of one leg, and then our other leg obviously needs to come up and recover going into the next step. So between the propulsion off the one leg and the knee drive of the other, we have this huge rotation that's occurring at the pelvis and at the hips, causing us to rotate in the direction towards our propulsion leg, the leg we're pushing off of. Now, in order to counteract that huge amount of rotation that's happening at our pelvis, we've got an opposite arm drive, followed by the other arm coming back. This movement creates a huge amount of counter rotation at the torso. So what happens is we have this rotation at our pelvis in one direction, and then this rotation at our torso in the other direction. Ultimately, what this does is balance out at the midline so that we can stay running straight or whatever direction we're trying to run. This means that our core muscles don't have to work so hard to keep everything straight. Our body is basically doing that on its own. Now, without anything to balance or counteract that rotation, we have a couple things occurring. One, it makes it very difficult to actually stay in line with the direction we're trying to run because we're constantly getting turned in another direction, and this rotation is basically traveling up our spinal column and causing our whole body to twist as we're running. And then two, because we have all of this rotation occurring at our pelvis and at our trunk, at our spine, our trunk or our core muscles have to turn on like crazy to counteract all this rotation that's happening at our spine. And this is just a massive waste of energy because a huge component of our power and our strength and our endurance lies in our movement economy. And if you're an athlete competing in a sport where you need to last 60, 80, 90 minutes, that energy dissipation, that extra energy usage is going to make a huge difference. If you look at marathon runners, obviously they are, yes, incredibly fit. They've got a ton of muscular endurance and their muscles are very efficient at utilizing energy. Their tendons are very efficient at absorbing and releasing kinetic energy. But probably the biggest component of the sustainability over such long distances is the fact that they are so mechanically efficient. They are wasting so little energy over the course of their running that they're able to sustain much higher power outputs over much longer distances. And one thing I'm going to challenge you to do to try and get a better idea of what I mean by how hard your core has to work to counteract this rotation, go to a track or a field anywhere and give yourself a huge bear hug and then try to run as fast as you can. You're going to have a very difficult time staying straight, and you'll notice that you get a lot more tired a lot quicker. So let's take this back to our jumps. When you're jumping off of one leg, the opposite knee is coming up, causing a rotation at your pelvis. So if you're jumping off of one leg and you have a counter rotation, but then the other arm's coming up at the same time, these things are balancing out anyway. but you still have that rotation that's happening at your pelvis. So even though you've got that swing and that momentum from your arms, you're getting twisted with every jump, and so your core muscles are having to work harder just to keep you straight. So if you're performing your hurdle jumps, your box jumps, you're slowly getting twisted out of the direction that you want to go. And I really don't want to see any comments talking about, oh, this makes my core work harder. Maybe this is good. Maybe this is a good thing. There are times when we may want to train trunk rotation. That cross arm sprinting drill is actually really effective for certain components of running. But when it comes to regular movement mechanics and running mechanics, you don't want to enforce this. If I could literally get any part of this entire video to sink in, let it be right here, right now, this little clip. We do not want to train inefficient movements. If you perform this properly, you're not only enforcing proper running mechanics, you are maximizing mechanical efficiency and you are reducing wasted energy. And when a game's coming down to inches and minutes on the clock, you need this energy. Do not do this wrong. The fact that this allows us to train unilateral power output in the context of proper sprint mechanics, but also allows us to maximize our movement economy, this is great. It's a 2-for-1. We're getting 2 birds stoned at once. Now this can be a little different with lateral movements because the amount of rotation we're actually getting at our pelvis is different. So for the counter rotation, we may chop across more. That is a future video. The only time I could maybe see some justification for single leg jumps with a double arm swing would be something like an approach jump in a sport like basketball, but this goes a lot deeper than just the arm swing. There's a lot going back into that penultimate step. That's not something I'm going to get into today. PJF Performance has a lot of good stuff on that. I can link that in the description. But for the vast majority of athletes, we need to have that opposite arm drive to counteract that knee drive and that hip extension. All right, I really hope you enjoyed the video, guys. I hope you're able to apply this to you or your athletes training. Please drop a like or comment on this video if you enjoyed it, and please share with your friends if you think that they could benefit from this, because at the end of the day, this is real life. Be ready to perform.